I'm pretty sure this is one of those things that makes everybody want to get into physics teaching, playing with a Van de Graaff generator. So the Van de Graaff generator I have down here in the lab is plugged in. And a Van de Graaff generator is a pretty simple device if you've never messed around with one. There's a electric motor in the base that can be rotated at different speeds, though our particular one in the department, you have to get it up to almost maximum speed before the actual band starts turning in there. Then there's a clear tube in here that has an enormous rubber band in there, and we can actually take the lid of this off. Down inside the Van de Graaff generator, the rubber band turns over a pulley up at the top, and near that pulley is a little piece of wire screen that's connected by a wire to this metal sphere that sits on top of the Van de Graaff generator. And we do lots of fun things with this. The classic, of course, is to have somebody touch the Van de Graaff generator and have their hair stand up. My hair is not so much anymore, and so it doesn't really work that impressively on me, so I'm going to try to do a few other things with the Van de Graaff generator to just show you a few demonstrations that I've done in the past with this. So we'll turn this thing on and get the rubber band turning. And why not start out by shocking ourselves a little bit? I always do this. I use the back of my hand because it hurts less, but you can see there's sparks jumping from the Van de Graaff generator to me, or if I use this little grounding contact, you might be able to see, I'm not sure if you can see the sparks in there, but you will see sparks jump from the Van de Graaff generator over to this. Let it build up a little bit. So that's all fun and good. I'm going to go ahead and turn the Van de Graaff generator off temporarily, and I always get shocked turning the dial off because it builds up enough static down there as well. I don't have the long hair, but I'm going to go ahead and give the Van de Graaff generator its own long hair. Turn that back on and observe what happens. I believe you can still get, a little spark off of the bits of paper there, though there's much more on the Van de Graaff generator itself. And notice if we do discharge the Van de Graaff generator, those return to their original position. So we'll take my phony hair off. There. Ever popular stack of pie plates. So here I've got about 10 of these aluminum foil pie plates you can get at grocery stores. You can watch and see what happens there. We can see how the Van de Graaff generator interacts with our B&T tapes, so I'm always leery of this holds a lot more charge than the B&T tapes did and might overwhelm things there, but I'm going to get some charge on the Van de Graaff generator going. And here's my B tape, and it is from out here repelled away from the Van de Graaff generator. Here is my T-tape, and even at a distance, very much attracted to the Van de Graaff generator. Ow. All right. And the final one, I haven't tried this, but I used to enjoy doing this when I taught high school physics. So this is just a standard fluorescent light bulb that I actually stole out of the ceiling over on the other side of the lab. And so I'm going to make myself part of the system and just suck it up and get shocked a few times. And then take my light bulb and see if I can get it near. There we go. I got some piping up at the top of the ceiling. Is that a good discharge? There we go. I don't know how well this is translating on video, but I'm getting brief blinks of my light bulb when I connect this to somewhere that is ground in the system. So again, if you don't have a Van de Graaff generator and you're doing this from afar, hopefully this video showed you a few things. You can Google Van de Graaff generator, YouTube, and there's a bunch of demonstrations on there as well. Ouch. But if you have one in your classroom, I'd encourage you to play around with that as well.